Good morning or afternoon, ladies and gents. For our lesson today, what we'll be looking at is permutations with restrictions. Now, just for reference, there's going to be a few sets of restrictions we're going to look at, but please be aware that in the real world with anything, there are going to be restrictions in place, hence why we're observing it today. As an example, with any of the natural sciences you might be studying, such as physics, biology, or chemistry, in anything you might possibly want to do, there will be restrictions based on it there. So for our learning goal, it'll be how to recognize how some permutations have restrictions necessary to understand before solving. So for the first one, permutations of like objects. Effectively, the number of permutations of n objects, of which n1 is alike, n2 is alike, and so on, and nr are alike. So how do you draw this one? Or the formula, I should say. N factorial divided by n1 factorial times n2 factorial, etc., for nr factorial. So for our first example, how many ways can the letters of the word algebra be rearranged? Now, because algebra has effectively 7 letters, we know that n is equal to 7, meaning that n factorial will also be equal to 7 factorial. What we're trying to do is find any repeated letters. In this case, just the letter A. So that means that nr, or n1, however you'd prefer writing it, is equal to 2, meaning that nr factorial is equal to 2 factorial, which, by the way, everyone, 2 times 1 is just 2. So, substituting it into our formula, 7 factorial divided by 2, 5,040 divided by 2, this gives us 2,520. And because this is a worded question, you can see I've also applied a worded answer. The letters of the word algebra can be rearranged 2,520 ways. Now for our next component, or our second example, find the number of permutations of the letters in the word riffraff. So just have a quick pause. What I want you guys to do is try and stop, figure out how we'd answer this before we go on. Now, if you read the word riffraff, you can see it's got 8 letters, which means n is equal to 8. If you look for any repeated letters, there are only 2, R, which is repeated twice, and F, which is repeated 4 times. So that means that n factorial will be 8 factorial, n1 factorial will be 2 factorial, and n2 factorial will be 4 factorial. So effectively, 8 factorial divided by 2 factorial times 4 factorial, which provides us the answer 840. Now for the next thing we're going to observe, arranging objects in a circle. If there is a set placement for the options, then the quotient must be n. So how we write this one down, guys? N factorial divided by n. So for example 3, you are asked to arrange 7 people around a round table. How many permutations could be made? So we know our number, or n value, is 7, meaning that n factorial will be 7 factorial. So we just substitute these in. 7 factorial divided by 7 gives us 720. For the final restriction we'll be observing, it'll be arranging objects where certain objects must be together. So, if certain objects must remain together, then they are treated as one object. So kind of think about this, guys, like pairs or groupings. If you're with 6 people, if you're with 6 people, and 2 of those people are in a relationship, you don't treat them as individuals, you would treat them as one pair. Now remember that, one pair, so 1 times 2. So for our fourth example, if Justine and Joe must sit together alongside 6 other people, how many ways can they now be rearranged? So we have to remember, there's a total of 8 people, but Justine and Joe are treated as one person. So if we were to write this out, because we have to remember it's one pair, 1 times 2, times, and then we think about the other rearrangements here. 1 times 2 times 3, all the way on to 6, because we've got a collective of 8. So that gives us the answer of 2 factorial times 6 factorial, just simplifying it down. So 2 times 720, which is 1,440. For our final example, 12 students are arranged around one table, but 3 must sit next to each other. How many permutations can be created? So we know we've got a collective total of 12, but 3 of those must sit together. Now we could effectively multiply this out like we did before, but because we know we can simplify this into factorial notation, that's what we're going to do. So let's start with our larger number, 10 factorial. Think about it. 1 times 2 times 3x onwards to 10, because 3 of those people are treated as just 1. So 9 plus 1, 10. Those other 3 also have to be counted, so it'd be 1 times 2 times 3. Remembering, we're thinking about how they're seated around a circle table or a round table, so we've got 6 possible ways that could occur. However, because we've got 10 seats, we need to also divide it by its number. So 10 factorial times 3 factorial divided by 10. Let's expand this out and then simplify. It gives us 2,177,280. And that's the end of our lesson. I'll provide all the questions for you guys to complete shortly. Thank you very much.